So now we're going to focus on finding all of the roots of a polynomial. So remember, some of our roots are visible and some are not, because you could have an equation that has, this one has 1, 2, 3, 4 real roots, but it could also have some imaginary roots, right? So it could have, 2 or 4 imaginary roots. So a few things that you need to know about this. All the possible roots. So the key word is possible. So if I want to find all the possible roots, and this is what we used a lot before we actually had the graphing calculators. But if I asked you what are all the possibilities for the roots on this equation up here, let me give you an equation. So let's say we have 2x to the fourth plus 3x, cubed minus 7x plus 6. So what we're going to do is we're going to assign two initials, or variables. We're going to call this, this guy on the end is going to be my p variable, and my first leading coefficient is q. So the constant term, or the constant term is my p variable. So this is p. And my leading coefficient, it has to be the coefficient with the highest degree, right? So my highest degree is 4 here. So I want the coefficient that goes along with x to the fourth, so that's 2. And what I'm going to think of is I'm going to think of all the possible factors of my p. So all my possible factors of p, I'm just going to list those. Those would be, 1 and 6 and 2 and 3. Can you see that those are all the factors? Those are all the factors of this 6. 1 times 6 is 6 and 2 times 3, and there's no others. Okay? And then I'm going to do all the factors of my leading coefficient. So that's just going to be 2 and 1, right? So 1 and 2. There are no other factors there. So now what I have to do is systematically I have to combine all of these. So watch what I do here. So I'm going to do 1 over 1. Sorry. 1 over 1 and 1 over 2. 6 over 1 and 6 over 2. 2 over 1 and 2 over 2. 3 over 1 and 3 over 2. So now what I can do is I can go ahead and eliminate any duplicates that I have. So can you see that 1 over 1 and 2 over 2 are the exact same thing, because don't they both equal 1? So I'm just going to go ahead and get rid of one of them. It doesn't matter which one. I'm going to get rid of that one. And then can you also see that 6 over 2 simplifies to 3, and I have 3 over 1 over here, right? So 6 over 2 and 3 over 1 equal exactly the same thing, so I'm just going to get rid of this one. It really doesn't matter which one you decide to get rid of. And that is it. Those are all of my duplicates. So my answer would be just what's left in simplified form. So I'm going to, I'm kind of running out of room here. So I'm going to list positive and negative, because I have to do the positive and negative of each one of them. So I'm going to have positive and negative 1, positive and negative a half, positive and negative 6, positive and negative 2, positive and negative 3, and positive and negative 3 halves. Okay, so let's do another one of those. Okay, so here's another polynomial. So let's figure out all of our possible roots. So what I want you to notice is the word possible starts with p, and the formula that we're going to use is p over q. We call it p over q, and remember our coefficient is p, our constant term is p, and our leading coefficient is q. So all the factors of 12, so I'm going to list those out here. So I'm going to have 1 and 12, 2 and 6, and 3 and 4. And all the factors of q, which is 3, is only 1 and 3. 1 and 3. So now I'm going to list them all out. Remember, come up with your own systematic way. If you don't like what I'm doing, make sure you're going systematically so that you don't accidentally leave any off. So I do 1 over 1, 1 over 3, 12 over 1, 12 over 3, 2 over 1, 2 over 3, 6 over 1, 6 over 3, 3 over 1, 3 over 3, and 4 over 1, and 4 over 3. So now I got to go through and eliminate any duplicates that I have. Oops, this didn't come out very well. Let me write that again. This is a 12. Oops. Okay, so my duplicates are going to be, where are my duplicates? I have a 1 over 1, a 3 over 3, so I can eliminate, those are both equal to 1. I have a 4 over 3 and a 4 over 1, they both equal to 4. I think that's it. If I miss any, I apologize, you guys. Okay, so remember, the other trick, or the other thing you have to remember is you have to put a positive and negative in front of each one. So it's positive and negative 1, positive and negative a third, positive and negative 12, positive and negative 2, positive and negative 2/3, positive and negative 6. Oh, 6 over 3 is 2. There's another duplicate. Can eliminate that one. Positive and negative 3, positive and negative 4, and positive and negative 4/3. Okay, so what this means is that if I have a parabola, or not a parabola, excuse me, a polynomial. I can delete some of this. So what this means is if I have a polynomial, I don't want to delete all that. Oh well. If I have a polynomial, that huge list, when I do my synthetic division, if this is my polynomial, what I can do is I can basically guess by doing my synthetic division. So let's say, 2 was one of my possibilities, right? So I can do 2, and I can set up my synthetic division. So it'd be 3, 0, 0, negative 7, 12, right? Make sure you are filling in those missing terms, right? I don't have an x cubed or an x squared term, so I put in 0. And if I went through this, I'm not going to do this, but if I went through and did my synthetic division, if I ended up with a 0 down here, then that says 2 is in fact a root. Okay, it is an x-intercept. It's where it's crossing. So before we really were able to look at the graphing calculators, we had to do these all manually. We would have to plug and chug and try every single one of those until we found a root. Okay. So here's a polynomial, and our task is to find all roots. So we are going to find all roots. But keep in mind that some of our roots can be real, rational, or imaginary. Okay, so we can have rational, irrational, or imaginary. Okay, so that's what we're gonna do. So what we're gonna do is, the first thing I'm gonna do is, because you guys can do this, you're gonna look at the graphing calculator. So I went ahead and I plugged this in on my calculator, and I got something that looks like, if you guys go ahead and do this, you might want to stop your calculator and do this. It kind of looks like this. Okay, so at first glance it looks like, you're like, oh good, I've got a root at 1, and it looks like I've got another one at like 3.5. That's kind of what it looks like. I'm not quite sure. So if I think that there's 1 at 1, and definitely that would be part of my P over Q, right? So if I looked at that, 1 is definitely, positive 1 is a possibility, because if I listed all the factors of 4 over all the factors of 2, I would get 2 over 2, which would give me 1, right? So I'm going to go ahead and I'm just going to try it out with synthetic division. That's what's nice about synthetic division. It's quick and fast. So I'm going to list all my coefficients, so negative 10, 12, and negative 4. Notice I'm not missing any, so I'm going to do my synthetic division, bring down the 2, multiply, I get 2, I get negative 8. I get negative 8, I get positive 4, I get positive 4, and voila, I do get 0. So remember, that means that if you end up with 0 as a remainder, that means positive 1 is a root. So that is one of my roots. Remember, my question was find all roots. So I'm going to put down here's my answer box down in the bottom. So I've got 1. That's one of my roots. Okay, but I've got 2 more. If it tells you to find all the roots, irrational, and imaginary, then we are in fact looking for 3 roots. If my highest degree is 3, I'm going to have 3 roots down here. So I'm going to have I need 2 more. So remember, when you do your synthetic division and you end up with 0 as your remainder, what is this guy right here? Well, if we started out with a 3rd degree equation, this is just a quadratic, right? isn't this, and you don't have to write this, but isn't this 2x squared minus 8x plus 4? Because remember, you reduce your degree by 1, and you write out all your coefficients. And what do we know about the quadratic formula? We can use, the quadratics, we can use quadratic formula, right? So that's the beauty of getting it down. If I can just reduce a third degree down to a quadratic, I've always got the quadratic formula in my back pocket. If I start out with a fourth degree equation, okay, if my equation up here is 4, okay, if I have a fourth degree, then if I can do 2 sets of synthetic division, which we'll do in our next example, then I still get a quadratic. I can get down to a quadratic. So now if I do my quadratic formula, and I'm not, actually I'll do one of them, and the next one I'll skip this step. If I do my quadratic formula, I end up getting 8 plus or minus 64 minus 4 times 2 times 4 all over 2 times 2. And that ends up being, what do I get? I get 8 plus or minus 4 root 2 over 4. I simplified that a little bit. And long story short, that becomes 2 plus or minus root 2. So on my calculator, what I can do is I can go ahead and I can do 2 plus root 2, and I'm going to end up getting a decimal, which is okay. I'm going to get, if I add it, I get 3.41. And if I do 2 minus root 2, I end up getting 0.58. And as in a summary, you got a third degree equation, you're going to have 3 roots. And these happen to be all, real numbers, which is great. I'm sorry, this is a point. This is a decimal. Okay, and at first glance, when I first graphed this on my graphing calculator, it looked like there were only 2 roots. But if you look at this a little, and if you enlarged it using your zoom box, you would see that this actually, and I drew it kind of accurately here, it does go up, crosses the x-axis, and then goes back down. So that's why there were, in fact, 2 roots here. Okay, so here is a problem. Here's a fourth degree equation, and when I graph it on my graphing calculator, it looks like this graph right here. So this is basically the graph, and I can tell from the graph that there looks like there's a root at -1. So I'm going to go ahead and set up my synthetic division. So I'm going to get 1. Remember, I'm missing an x cubed term. -16 and -15. So make sure you put that 0 in. And when I do my synthetic division, I'm going to let you do all this, but I do end up getting 0 down here. Oh, actually, I do need to write this down because I need my answer to be down here. So I'm going to get my final answer when I do this synthetic division is going to be -1, -1, and -15. So remember, what does this give me? So this is a cubic equation, right? You reduce your degree by 1, so this is really x cubed minus 2x squared, or minus x squared, minus x minus 15. From here, and you haven't seen this yet, I can continue on with my synthetic division. That's why I like to, when I get a 0, I like to put my remainder in a box because I want to make sure that that is no longer part of my equation, because then I don't need to rewrite my synthetic division. So it looks like from the graph, that 3 is also a root. So let's check that out. So if I do my synthetic division here, I'm going to get 2, and I get 6, and I get +5, and I get +15, and oh, look at that, I get 0 again. So that means that I have 2, so down here in my answer box, I've got 2 roots, one at -1 and one at 3. But remember, I'm starting out with a fourth degree equation, so there needs to be 2 more. And according to my graph, there are only 2, okay? There are only 2 on the graph. So where are my other 2? Well, the other 2 are imaginary, and if I do my quadratic equation, based on this quadratic here, remember, because when I do my synthetic division, oops, sorry, this is my goodness, this is a fourth degree equation, so when I do my first set of synthetic division, this comes down to a third degree equation, and this is a second degree equation. So now I can, if I set up my, and if I need to, you can write this is just going to be x squared plus 2x plus 5. And if you do your quadratic equation, you're going to end up with -1 plus or minus 2i. You can do that on your own. That's just the whole quadratic equation. And these are my other two roots. So my other two roots are going to be -1 plus or minus 2i. So now I have a total of 4 roots, 1, 2, and then 3, 4. Okay? And you can't simplify this anymore, especially when you have imaginaries. You can't do decimals with them. So you just leave it in the form -1 plus or minus 2i. And that's how you find all the roots of an equation.